Lesson 410, Scale Drawings and Models, you will solve problems involving scale drawings. A scale drawing or a scale model is used to represent an object that is too large or too small to be drawn or built at actual size. The scale is the ratio of a length on a drawing or model to its actual length. So the scale is the model compared to the actual. I always think about this in terms of if you need to know something, you ask Ma. So model over actual. Oftentimes you can write a proportion to solve problems that have to do with scale models or drawings. So right here is the recipe you can use to set up a proportion. Remember, proportion is two equal ratios. So over on the left side, I write down the scale that's given to me in the problem. And then on the right side, I put the model measurement over the actual measurement. Usually it's one of these two pieces that you don't know, and you'll have a variable there, and then the other one is a number in the problem. And then you go through and solve it for the unknown like we did earlier in the chapter. For example, on a map, 1.5 centimeters equals 50 kilometers. If the two cities are 5 and 2/10 centimeters apart on the map, how many kilometers apart are they? Well, I'm going to set up my proportion using my recipe. The first thing I'm going to write down is I'm going to write down my scale. My scale is 1.5 centimeters, or 1 5/10 centimeters, over 50 kilometers. The labels will help me keep things organized. Now remember it's going to be model measurement over actual, and if you're not sure, you ask model over actual. If the two cities are 5.2 centimeters apart on the map, well, a map is going to be a model, so that's going to be on the top, 5.2 centimeters. How far apart in kilometers are they? We don't know that measurement, so we're going to go ahead and put X. Now to solve this, remember we multiply diagonally. I start with the variable, the diagonal with the variable. 1.5 times X is going to equal 50 times 5.2. 50 times 5.2, or 5 and 2/10, equals 260. Now to solve this for X, instead of multiplying by 1.5, you would divide by 1.5. So 260 divided by 1 5/10 equals 173.3 repeating, or 173 1/3. And then that would be in kilometers. In example 2, we're going to try and find the scale. One of the models of a dinosaur used in the filming of the movie was only 15 inches tall. In the movie, the dinosaur appeared to have an actual height of 20 feet. What was the scale of the model? Well, remember, the scale is always the model over the actual. So the model was 15 inches tall. And it appeared to actually be 20 feet in the movie. So the actual is going to be 20 feet. Now, if we want to figure out this scale, what we're going to do is we're going to figure out what 1 inch is going to equal. So we know that 15 inches equals 20 feet. We're going to figure out what 1 inch equals. We're going to figure out how many feet that is equal to. So now we're going to go ahead and go like this. 15 times x, or 15x, equals 20 times 1, which is 20. And now you divide both sides by 15. So x is going to equal 1.3 repeating, or 1 1/3. So that means that the scale is going to be 1 inch equals 1 1/3 feet. So again, what we did is we wrote down the model measurement over the actual measurement, and then we went to figure out what 1 inch was going to equal how many feet, and we would solve the proportion to find out that 1 inch equals 1 1/3 feet. You may want to pause the video and try the next one on your own. The model Mr. Vicario made of the building he designed is 25 6/10 centimeters tall. If the actual building is to be 64 meters tall, what is the scale of his model? Well, remember, it's the model measurement over the actual measurement. So the model measurement was this right here, 25 6/10. And the actual was 64 meters. So now what we want to figure out is what 1 centimeter is equal to. So I'm going to go ahead and put 1 centimeter over x, because we want to figure out how many meters that's going to be equal to. Now we're going to go like this and say 25 6/10 times x is 25.6x equals 64 times 1, which is 64. Now divide both sides by 25 6/10. (64) divided by 25 6/10 equals 2.5, or 2 5/10. So it's going to be 2.5 meters. So that means our scale is going to be 1 centimeter equals 2.5 meters. All right, our next type of example is to find the scale factor. Scale factors are similar to scales in that you're going to compare the model to the actual, but the key here is a scale factor has to be in the same unit. So if they're not in the same units, you need to change it so it is. The first thing you're going to do is write down the scale, change to the same units if needed, and then simplify. So if you look over here at our first example, 1 inch is equal to 15 feet. So we're going to go ahead and write that down like this. 1 inch over 15 feet. Now we have different units, so we need to change it to be the same. You want to change it to the smaller unit of measurement. So I'm going to change 15 feet to inches. There are 12 inches in 1 foot, so we're going to go ahead and take 15 times 12 to figure out how many inches that is. 15 times 12 is 180. So this is really equal to 1 inch over 180 inches. Now, since these are both in inches now, the labels would cancel out, and the scale factor is 1 over 180. We do not need to simplify this one. So a scale factor of 1 180th means that it is 1 180th the size of the original. The model is 1 180th the size. If it was a scale factor of 2, that would mean the model was 2 times the size of the original. Let's move on to the next one. 10 centimeters equals 2.5 meters. So I'm going to go ahead and write down that scale. 10 centimeters over 2.5 meters. Well, we need to have them in the same unit, so I'm going to go to the smaller unit, which is centimeters. So I'm going to leave the top one as 10 centimeters. And we're going to make the bottom one into centimeters. There's 100 centimeters in a meter. So I'm going to take 2.5 times 100. When you multiply by 100, you move the decimal 2 places to the right. So that's going to be 250 centimeters. Now I can get rid of my centimeters label, and I have 10 over 250. 10 over 250 is going to be simplified. It's going to be simplified by dividing both the numerator and denominator by 10. 10 divided by 10 is 1, and 250 divided by 10, you'd move the decimal 1 place to the left, so it's 25. The scale factor is 1/25. That means the model is 1/25 the size of the original. All right, our last type of problem is to construct a scale model. It says the Statue of Liberty stands about 305 feet tall, including the pedestal. Christina wants to build a model of the statue that is at least 20 inches tall. Well, the first thing we're going to do is we're going to find out what the scale is if the model is 20 inches tall, because we want it to be at least 20 inches tall. So we're going to have the model, remember it's model over actual. I'm going to put 20 inches for the model. And then the actual is 305 feet. So we want to figure out what that scale is. So we're going to figure out what 1 inch is equal to in feet on the actual thing. So I'm going to write 20 inches over 305 feet equals 1 inch over x feet. And then we're going to solve the proportion. 20 times x is 20x. And then 305 times 1 is 305. Now you would divide both sides by 20. We're going to take 305 divided by 20, and that's 15 and 25 hundredths. It's going to be that many feet. So one inch equals 15.25 feet is our scale. Have to be at least that to make it at least 20 inches tall. So now using the scale, we can find the height of the pedestal on the model if the actual height is 154 feet. So if you know that the actual height is 154 feet, we're going to write down the scale first. 1 inch is 15.25 feet. So 1 inch on the model is 15.25 feet on the actual. And if we know that the actual height of the pedestal is 154 feet, we can then figure out how tall to make it on the model. So this information here was something that you could find out, like the actual height is 154 feet, and you can figure out the height of the model by solving this proportion. 15.25x equals 1 times 154. Now you would divide both sides by 15.25. So 154 divided by 15.25. That's going to end up being about 10.1. It's kind of an ugly number, so we're just going to round it to 10 and 1/10. 10 and 1/10 feet, or sorry, inches. So if we wanted to make a model that's at least 20 inches tall, the pedestal part of the Statue of Liberty would have to be about 10.1 inches.